Hi learners, I am R. Amudha, Department of Mathematics, Nanda Engineering College, Erode. So now we are going to talk about the Laplace transformation. So first of all, the definition of Laplace transformation. Let a function f of t be continuous and defined for positive values of t. The Laplace transformation of f of t associates a function s defined by the equation L of f of t equal to f of s is equal to integral over 0 to infinity e power minus st into f of t into dt. Here f of t is a various function. Here f of s is said to be Laplace transform of f of t and it is written as L of f of t, that is f of s. Next, the uses of Laplace transformation. First of all, it is used to find the solution of linear differential equations as well as partial. And then second one is, this method is especially useful in tackling problems of electric circuits and other requiring particular solution. Necessary condition for the existence of the Laplace transformation. So first one, f of t should be continuous or piecewise continuous in the given closed interval a comma b, where a is greater than 0, that is a is positive. And then second one is f of t should be of exponential order. Next to see about some important results. So first one, e power infinity. So e power infinity is infinity, and then e power minus infinity value is 0 and e power 0 value is 1. So that is anything power 0 value is also 1. The next result is integral of e power ax into sin bx into dx, which is equal to e power ax divided by a square plus b square into a sin bx minus b cos bx. The next result is integral of e power ax into cos bx into dx, which is equal to e power ax divided by a square plus b square into a cos bx plus b sin bx. Next, the basic result is sin hat, which is equal to e power at minus e power minus at divided by 2. The next result is cos hat. So cos hat equal to e power at divided e power at plus e power minus at divided by 2. Next, we see about basic properties of Laplace transformation. So the first result is L of 1 equal to 1 divided by s. So already we know that the Laplace transformation definition is L of f of t equal to f of s equal to integral over 0 to infinity e power minus st into f of t into dt. Here f of t value is 1. So substituting f of t equal to 1 in the Laplace definition, we get L of 1 is equal to integral over 0 to infinity e power minus st into 1 into dt. Next, the integral of e power minus st into dt value is e power minus st divided by minus s to the limit 0 to infinity. So 1 divided by minus s is a constant term, so taking outside the value, we get, first substituting upper limit infinity, we get e power minus infinity minus of the lower limit is e power 0, which is equal to, so already we know that the result e power minus infinity value is 0 and then e power 0 value is 1. We get minus 1 by s into 0 minus 1 is equal to 1 divided by s, that is L of 1 equal to 1 by s. Next, prove that L of e power at equal to 1 divided by s minus a. Here f of t value is e power at. So already we know that the definition of Laplace transformation is L of f of t value is integral over 0 to infinity e power minus st into f of t into dt. So substituting f of t equal to e power at, we get integral over 0 to infinity e power minus st into f of t value is e power at into dt. So after substituting the base value is same, then add the numerator value. We get integral over 0 to infinity e power, so taking outside the negative value, that is e power minus of s minus a into t into dt. Next, integral of e power minus of s minus a into dt into t into dt value is e power minus of s minus a into t divided by minus of s minus a to the limit 0 to infinity. So 1 divided by minus of s minus a is a constant value. So taking outside the value, we get e power minus of infinity minus the lower limit is e power 0. So already we know that e power minus infinity value is 0. Minus of e power 0 value is 1. Next, minus of minus plus, that is 1 divided by s minus a. Similarly, L of e power minus at which is equal to 1 divided by s plus a. For example, L of e power 3t is equal to 1 divided by s minus 3. Here a value is 3, that is 1 divided by s minus 3. Next, second one, L of e power minus 3t which is equal to 1 divided by s plus 3. So substituting a is equal to 3, we get 1 divided by s plus 3. Next, third one, L of e power lambda t. Here a is equal to lambda. So substituting a is equal to lambda, we get 1 divided by s minus lambda. Next, fourth one, L of e power minus pi into t which is equal to 1 divided by s plus pi. Next, prove that L of sin at which is equal to a divided by s square plus a square. Here f of t value is sin at. So already we know that the definition of a Laplace transformation. So L of f of t value is equal to integral over 0 to infinity e power minus st into f of t into dt. So substituting f of t is equal to sin at, we get integral over 0 to infinity e power minus st into sin at into dt. Already we know that the formula integral of e power ax into sin bx into dx which is equal to e power ax divided by a square plus b square into a sin bx minus b cos bx. So substituting a is equal to, comparing these two equations, we get a is equal to minus s and x equal to t and a is equal to b. Here a is equal to minus s and b equal to a and x equal to t. We get L of sin at is equal to e power minus st divided by s square plus a square into minus s into sin at minus a cos at to the limit 0 to infinity. First substituting the upper limit infinity minus of the lower limit 0. And finally we get e power minus infinity value is 0, that is 0 into anything 0. Next, substituting the lower limit, we get e power 0. E power 0 value is 1, that is 1 divided by s square plus a square into sin 0 value is 0 and then cos 0 value is 1, that is minus a. So minus of minus plus, so a divided by s square plus a square. So 0 plus a divided by s square plus a square is a by s square plus a square. Similarly, we can prove L of cos AT equal to S divided by S square plus A square. Here f of t value is cos AT. Next, substituting f of t equal to cos AT in the Laplace definition. We get L of cos AT equal to integral over 0 to infinity e power minus st into cos AT into dt. Since integral of e power ax into cos bx into dx equal to e power ax divided by a square plus b square into a cos bx plus b sin bx. So comparing these two equations, we get a value is minus s and b value is a and x is equal to t. Substituting this value in the above equation, we get e power minus st divided by s square plus a square into minus s cos at plus a into sin at to the limit 0 to infinity. So first substituting the upper limit, we get e power minus infinity value is 0. So 0 into anything 0. Next substituting the lower limit 0, that is e power 0 value is 1. That is 1 divided by s square plus a square into minus s into cos 0 value is 1. That is cos 0 1 minus s into minus 1, that is equal to s divided by s square plus a square. For example, L of sin at equal to a divided by s square plus a square. Here a is equal to 2. That is L of sin 2t equal to 2 divided by s square plus 2 square, that is 4. Next, L of cos 2t equal to s divided by s square plus a square. Here a value is 2, that is a square equal to 4. Then the value becomes s divided by s square plus 4. Next, we can prove that L of sin h at equal to a divided by s square minus a square. Here f of t value is sin h at. So substituting f of t equal to sin h at in the definition of Laplace transformation, we get integral over 0 to infinity e power minus st into, here f of t value is sin h at into dt. Here sin h at is equal to e power at minus e power minus at divided by 2. Next, taking Laplace transform on both sides, we get L of sin h at is equal to 1 divided by 2 into L of e power at minus e power minus at. Next, multiplying Laplace transformation on both terms, that is 1 by 2 L of e power at minus L of e power minus at. So what is the result of L of e power at? 1 divided by s minus a. And then L of e power minus at result is 1 divided by s plus a. Next, taking the LCM of both 1 divided by s minus a and 1 divided by s plus a. That is s plus a minus of s minus a, that is minus s plus a. In the denominator term is a minus b into a plus b, which is equal to a square minus b square, that is s square minus a square. Here a value is s and b value is a. And finally, s term and minus s term cancel, which is equal to a plus a 2a. So 2a divided by 2 into s square minus a square. So 2 cancel, and then finally we get a divided by s square minus a square. Similarly, L of cos h at equal to s divided by s square minus a square. For example, L of sin h 5t, which is equal to 5 divided by s square minus 5 square, that is 25. So substituting a is equal to 5, we get 5 divided by s square minus 25. Then second example is L of cos h 7t equal to s divided by s square minus a square. Here a is equal to 7, we get s divided by s square minus 49. Next, L of t power n is equal to n factorial divided by s power n plus 1 if n is an integer. Here n is equal to 0, 1, 2, 3, etc. And then L of t power n is equal to gamma of n plus 1 divided by s power n plus 1 if n is not an integer. For example, L of t cube. Here n is equal to 3. 3 is an integer. Then substituting n factorial by s power n plus 1 formula. So substituting n equal to 3, we get 3 factorial divided by s power 3 plus 1. That is equal to 3 factorial is 3 into 2 into 1, that is 6. So 6 divided by s power 4. Next example, L of t power 1 by 2. Here n is equal to 1 by 2 is not an integer. Then we apply gamma of n plus 1 divided by s power n plus 1. Here n is equal to 1 by 2, which is equal to gamma of 1 by 2 plus 1, that is gamma of 3 by 2 divided by s power 1 by 2 plus 1, that is s power 3 by 2. So already we know that the result L gamma of n plus 1 equal to n into gamma of n. Then the value becomes 1 divided by 2 into gamma of 1 by 2 divided by s power 3 by 2. So already we know that the result gamma of 1 by 2. Gamma of 1 by 2 value is root of pi. That is 1 by 2 into root of pi divided by s power 3 by 2. Thank you.